Today we're going to look at solving logarithmic and exponential equations using the one-to-one properties. So what we're going to do is we're going to manipulate both sides of the equation so that they have the same base. And when I say the same base, what I mean is like 4 squared equals 4 to the x. Then we will cancel the exponentiation or logarithm. So in this case we cancel the 4's. And then we'd say 2 equals x. If we have more things in the exponents, we'd have to solve, and then check for extraneous solutions if it's a logarithm. So what does this look like? So if we see this, well, they are already written with the same base all together, if this is not 6 to something times 6 to something else. So we can just cancel this. What we're really doing technically is taking the log base 6 of both sides. Then we solve. Over here, we cannot just cancel them out. We need to first combine them using our exponent rules. So this is 5 to the 1 minus 2n minus 3n equals 5 to the 4th. Now, so that we have the same base on both sides, we can write 1 minus 2n minus 3n equals 4 by the one-to-one property. So 1 minus 5n equals 4, negative 5n equals 3, and n equals negative 3/5. Here we can use the one-to-one property because these are logs with the same base. As long as they're logs with the same base, we can cancel them out by the one-to-one property and say 2x plus 10 equals negative 3x. Subtract 2x from both sides. And x equals negative 2. Sometimes it's not already in that form. So now we have natural log of 24 equals this we combine with the product property, the natural log of 2x plus 10. Now we can exponentiate both sides, which by the one-to-one property gives us 24 equals 2x plus 10, 14 equals 2x, and x equals 7. Now I'm skipping over step 4 for these problems. We'll talk about step 4, checking our solutions in the next video. Here, they are not written as the same base. So we're going to have to figure out how to write these with the same base. Well, 36 and 216, both of those numbers should lend you to start thinking about the number 6. Hopefully you know 36 is 6 squared, and 216, we can write that as 6 cubed. So once we've done that, we can use our exponent rules to say that this is 6 times. Our exponent rules say we multiply, so negative 6x plus 3 equals 6 squared. So negative 6x plus 3 equals 2. Negative 6x equals negative 1, and x equals 1/6. So again, the big part of this problem was realizing that we can rewrite 216 as 6 cubed and 36 as 6 squared, and then we can use our one-to-one property. Here we have log base 19 of multiple things. So we're going to have to write it as a single log base 19 of n squared minus 3n equals log base 19 of 32 plus n. Let's see, what would this be? N squared minus 3n equals 32 plus n. Ooh, this gives us a quadratic. Subtract 32 and n from both sides, so n squared equal minus 4n minus 32 equals 0. Hopefully you remember your quadratics. N minus 8, n plus 4 equals 0. So our solutions are n equals 8 or n equals negative 4. Now this is a case where this is actually not a solution. Don't worry about that for this video, we'll talk about that in the next video. We have the same base on both sides, so we can just use the one-to-one property. Move everything to the same side, so 0 equals x squared minus 10x plus 24. So 0 equals x minus 6, x minus 4, so x equals 6 or 4. Lastly, this one is kind of annoying. We have 27, 243, and 1 over 27. Those are all powers of 3. This is 3 cubed. This is, I believe, 3 to the 5th. 3 times 3 is 9, times 3 is 27, times 3 is 81, times 3 is 243. Yes. And this is a negative exponent because it's a fraction, so 3 to the negative third. Combining the left side, we have 3 to the negative 3n plus 6, 3 to the 15n minus 15, and 3 to the negative 3. Combine these and get 3 to the, 12n minus 9 equals 3 to the negative 3. Now we can use our one-to-one property since they have the same base, and there's only one term on each side. (12n) equals 6, so n equals 1/2.